Thank you everyone for joining today's webinar, Battle of the AI Agents, Learn Why Domain-Specific AI Agents Win. I'll now pass it off to our field CTO, Utkarsh Contractor, to kick us off.
Thank you. Thank you, Anisha. Hello, everybody. Good morning, good afternoon, good evening, based on where you are. Welcome to the Battle of AI Agents, why domain-specific AI agents win in the enterprise. My name is Utkarsh Contractor, and yes, Contractor is my last name. But we will probably have to do another webinar to, tell you how that, transpired. So we'll probably not go there. I'm the founding member and field CTO at Aisera. Aisera is an agentic AI company that focuses on building purpose-built, domain-specific AI agents for the enterprise. And joining me today are Michael Worno and Vaishnav Garodia. Michael is a fifth-year PhD student at Stanford, whose research is focused on developing and evaluating foundational models for agentic AI workflows, and he's specializing in domains such as healthcare. Whereas Vaishnav Garodia, he's a CS master's student at Stanford University as well, who's extensively worked with agentic AI agents for the enterprise. So hello, Michael. Hello, Vaishnav. Thank you so much for joining us.
Thanks for having me.
Awesome.
Thank you. Yeah.
Awesome. Cool. So let me quickly, briefly introduce, the agenda for today. Let me tell you exactly what we're going to talk through. And, I'm hoping to have an exciting discussion with you all. And, please feel free to post your questions in the chat, and, we'll get to it towards the end of the discussion. So today's discussion essentially will focus on the classic benchmark. As you can see on the screen, and we are going to discuss this paper that was recently published and accepted at the ICLR 2025, the 13th International Conference on Learning Representations. The paper is formally titled, as you can see, Top of the Class, Benchmarking LLM Agents on Real-World Enterprise Tasks. This was accepted as part of a workshop on building trust in LLMs. And subsequently, we will go through this entire paper and we will discuss a few key things. One, what is the classic benchmark? What is this real world enterprise benchmark that we, are proposing to evaluate enterprise AI agents? Why is it important? Why do we need yet another benchmark? In the, abundance of so many benchmarks out there, why do we need another one, right? And what are the original contributions of this work? And what are its, more importantly, industry relevance? We'll review some of the data set that was used in this paper. We'll talk to the methodology and the code contributions, etc. We will also discuss the observations and results, and we'll talk through some of the next steps on how we see this grow into the future. And finally, we will end with some real world business implications and industry applications of this study and how we see this contributing to advance the field. So having said that, let me actually hand it over to Michael. So Michael, maybe you can help us set the stage, for AI agents. AI agents are the talk of the town. AI agents are the theme of 2025, right? But what are AI agents, right? How would you define AI agents, and why do you believe that they're becoming increasing relevant in the AI enterprise of today?
For sure. Well, first up, thank you, Utkarsh and Aisera more broadly for hosting us and enabling this great research. It's been a pleasure to collaborate with everyone, and I think this benchmark, represents a really awesome contribution to the broader literature on agents. I think it's just been an incredibly exciting time to be working in the space, and also to have the chance to look at real world production use cases of these agents, which I think will just become increasingly more important and essential to how enterprises carry out their business functions over the coming months, let alone years. Maybe to take a step back, what is an agent in the first place, and why do we care? I think Anthropic had done a really good job of crystallizing like what actually is meant by this term, and they define it as basically a system. An AI agent is a system where typically you'll have a large language model or a large vision model. So a huge model trained on lots of data. You could think of OpenAI's GPT-4 or Anthropic's Claude, right? Super large machine learning models that have a ton of capabilities. And what makes agents unique or interesting is that building on this core foundation model, an agent is able to dynamically direct its own actions and tool usage, maintaining its own control over how it decides to and executes workflows in order to accomplish higher level tasks. So whereas, a traditional large language model or vision language model is typically presented to folks as, inputs, outputs, a chatbot, you tell it what to do and it tells you a response immediately back. An agent, given a very high level kind of goal or task, will figure out not just what the answer is, but also what to do in the first place to arrive at that answer, and also how to do those steps to accomplish it. And so, we're basically taking these models from more static pieces of software to dynamic software that can potentially interact with many interconnected systems. And I think, to your point, there's just been an incredible amount of excitement, especially in the academic literature, about this new approach towards developing software and doing knowledge work. And the agentic kind of framework or problem formulation enables us to solve a lot of problems that previously were out of the reach of what you'd call traditional machine learning models, or more static software that wasn't really able to direct itself. So that is, in a nutshell, kind of what all the excitement is around agents. And it's been really, really cool to have been able to collaborate with the folks on this call to try to extend a lot of the academic research that we've seen in the space towards more real world production use cases like you
Awesome.
might
No,
see in
that
an
makes
actual enterprise.
perfect sense. And thank you so much, Michael, for that clear definition. I think that really grounds us for today's discussion. And having that, I guess, context in mind, I would love if Michael, you could maybe extend that a little bit to talk through what actually motivated this study, and what motivated us to develop yet another benchmark. I mean, there are so many benchmarks out there, but what, according to you, were the key gaps, and and what we were trying to address with this research and studies. Yeah.
Yeah. Yeah, I think that's a really great question. And yeah, to your point, there's a lot of existing agentic work and benchmarks out there in the literature. I think, the more you dive into the actual data, the more the shortcomings appear. And I think one of the key shortcomings of existing benchmarks is that a lot of them use synthetic data. And what I mean by that is it's not real, right? It's data that's maybe generated by another AI model or by a bunch of human annotators. And it's not actually reflective of real world data from what you'd see in a production deployment of agents. The other kind of piece of it is, not only is the data out of distribution, quote unquote, from what you see in the real world,
Right.
but also the metrics that a lot of these leaderboards and benchmarks focus on are also similarly different or too overly narrow compared to the metrics that you might care about if you were actually considering a real-world deployment of these agents. And so to give an example, as you can see on this slide, a lot of existing leaderboards focus only on the middle row of accuracy, basically how many tasks does the agent successfully complete, but don't really consider the other metrics that you see here that would actually matter a lot to a company considering deployment, like cost, for example, right? Or how long does it take for the agent to respond? That's latency, as well as security. Obviously, you don't want the agent doing random things or leaking customer data. And stability. You want the agent to be able to correctly respond when invoked multiple times, and not to give different responses depending on the time of day or the weather outside, right? And so with Classic, with the work that we'll discuss today, we really aimed to bridge both of these gaps in the existing literature by curating a data set of actual de-identified customer conversations from Aisera's production logs, and then to holistically evaluate agents across not just one, but the 5 metrics that you see on the slide here: cost, latency, accuracy, security, and stability. And that's where the benchmark gets its name.
Awesome. Awesome. Thank you so much. Vaishnav, is there anything else you would like to add there?
Yeah, I think as Michael was saying, that the enterprise adoption isn't just about like how smart an AI is, but about like how trustworthy it is, how practical it is in the real world. And that's how we came up to Class X, because it evaluates not just on accuracy, but like across all the factors. So let's say cost, like at an enterprise use case, even a small difference in the cost per query could amount to like massive infrastructure charges. So it's important to like know what the cost is, the latency, because even if like a longer response time would degrade the user experience, and like the users, as we know, have very low patience. They would just leave. The accuracy is of course vital. The stability means like slightly different way of phrasing the same question should not be triggering different workflows, but should be like stable enough to be able to get the same workflow multiple times. And finally, security, to make sure that in an enterprise use case, that we are not like making mistakes with the data privacy or responding in malicious manners. So together, like the classics benchmark allows enterprises to make informed trade-offs and make sure that they find the best model for their use case.
Awesome. Thank you, Vaishnav. So let's maybe deep dive a little bit more on, actually under the hood on what's happening in this work, right? So Vaishnav, maybe we can start with you, and can you perhaps walk us through, the data set, the approach, the methodology, basically the mechanics of what was done, like how did we come across selecting the data we wanted to select? What was the data that was selected? What was the methodology used to
Absolutely, yeah.
evaluations? Yes. Please
Yeah.
go ahead.
So we built Classic using 2,133 real-world user chatbot messages, and with 423 unique workflows, all sourced from Aisera, an enterprise AI vendor. So like we went through different domains that Aisera worked with, and then to ensure that we have like a wide spread of data and we are able to evaluate across like different sectors. And from all of these domains, we sourced like thousands of messages. And then after that, we did a lot of filtration steps, like filtering for like anonymity, and then taking out any like degenerate conversations, which could be defined in many ways, as in like conversations which had like just asterisks, for example, because like there are bad conversations in every users sometimes ask like random questions like that. And then taking out like conversations which had like bad language, which we didn't want in the data set. So we filtered it that way. And after that, we had a random program to select a number of conversations which matched like the length and the number of tones we wanted in the data set to have a wide sampling across like different number of tones, so that we can have a representation of like different kinds of conversation in the data set. And then eventually we came up with like this data set with 7 different domains of like fintech, medical, HR, IT, edtech, biotech, and banking, with a total of 2,133 messages to benchmark across. For the methodology, we designed a multi-class classification task. We give the user a message, and the agent has to pick the most appropriate workflow to trigger from the predefined set of workflows we provide them with. And along with the workflow, we provide them with the workflow description for every workflow, which is the same length for every single workflow. Like it's like 500 character description for every single workflow describing what the workflow does. We then evaluated the model across the 5 key metrics of cost, latency, accuracy, stability, and security. Importantly, all the messages were human annotated by 3 different human annotators to ensure that we have unbiased ground truth labels. So, and then we even like tested security using 500 jailbreak prompts, which we source differently from this data set. And then these jailbreak prompts are used to test if the model is like responding to malicious prompts, or it is just like safe enough to like recognize that this prompt should not be responded to.
Got
So
it.
overall, like it's benchmark rooted in real enterprise needs and like real enterprise data, as Michael said before.
Right. And that's actually a good point. So I know Michael touched on this before about the synthetic nature of the existing data sets, right? Which have been, been state of the art so far. So Vaishnav, what is your take on that? How is the data used in this study different from, data that has been used for previous studies?
Absolutely. That's a great question. I think like one of the most interesting observations I think we had after doing the study was that people in real world settings act very differently as compared to in like we assume that they would be acting in the synthetic data sets we had before. So in this data set, the average length of a user request was incredibly short, like just 36 characters, which is 3 times shorter than what it is in the other competing benchmarks, the synthetic ones. Users are like very low on patience. They immediately like ask a question. If they don't get the response, they ask like they will like maybe try once more. If not, they just want to get escalated to a human. So they're like very low patience and like very short messages, and they just expect the agent to be able to get what they're asking from that very small question. So it's very important that we test them on like real world data so that we get the real world performance, because in synthetic data, the performance can be also synthetic.
Got it.
If Michael has more to add to that.
I think that was super well stated. And I think the only other thing I would add is, for a lot of these domains, as you can see on the slide here, right? This is the IT domain from our data set. There's, almost 150 different workflows at any given time that can be triggered, right? That reflects the complexity and the specialized nature of a lot of these enterprise deployments, which, is hard to reflect in a synthetic data set that might only have, a dozen or a handful of potential workflows. And so that makes the challenge for the model of picking the right workflow significantly harder in this data set.
That's actually a very good point. And thank you for bringing that up. That actually, brings a question to mind before I move to, to more discussing the results, etc. So maybe, Michael, I can ask you this question.
Yeah.
Why do you think this was a fair setup? So, we have, domain-specific agent, and we have other agents built on foundational models. Can you talk about the fairness of this setup so that, we can put that in?
Yeah, that's a great question. So I think, a couple answers to this. I think with the general purpose models, right, really you're kind of limited by what's available. And for a lot of folks, it's prompt engineering, it's in context learning, it's providing the right examples, it's retrieval,
Right.
it's chain of thought, it's thinking, it's reasoning. And so we try to integrate these approaches and get the best performance that we can. But to your point, right, if a model is not purposely designed for a setting like this, it does naturally start at a disadvantage, and we do see that borne out in the results. I think, to your point, like out of the box, these frontier models are fantastic and they do have very strong performance. But for domains that require more specialized knowledge, like the IT domain, and there's a few others that we'll share in a few slides that kind of show larger performance gaps. It's really in these more specialized domains where you actually do see the deltas between the specialized domain-specific models and the more generic frontier models. And so I think, that point is very well taken. I think for general, internet knowledge, common sense, like there's really no difference. It's only once you get into kind of the nitty gritty where you do see the domain specific approach leading to pretty sizable performance gaps.
That makes sense. Yeah, no, thank you for answering that. That makes sense. Awesome. Cool. So I guess we should, probably move on to the next section, which is, actually discussing the results and insights and also challenges, during this particular study. So Michael, maybe we can start with you, right? Could you highlight some of the key outcomes of this study? What were some of the most insightful observations and conclusion, and maybe point out to one or two challenges that you had along the way?
Yeah, that's a great question. So as you can see on the slide here, we ended up evaluating the 4 different models that Vaishnav pointed out across all domains in our data set and the 5 metrics of cost, latency, accuracy, stability, and security. And what was very interesting was maybe I'll go kind of left to right in terms of cost. The domain-specific models are significantly cheaper, and I think that was probably not as surprising as some of the other findings. Like you'd expect a model that's geared towards a specific task to be able to do that task more efficiently. I think what was surprising was kind of the extent to which that was true, where the domain-specific approach with the Aisera model we tested ended up being significantly cheaper in terms of per token cost than some of the other models we looked at, up to even 5x for some of them. And I think this gap will increase as more expensive reasoning models that have higher amounts of inference time or test time compute get rolled out. For example, O1, O3, where they will get better and better accuracy, but at even higher costs. So I think the cost part was something initially early on that we were made sure to be aware of. In terms of latency, I think this was a little bit more of a mixed bag. I think it really depends on kind of your relationship with your model provider more than anything, given rate limiting and quotas and API access and things like that. So while we did see that some of the lighter models, so the domain-specific one, for example, were able to respond faster than some of the larger frontier models. I think with a little bit of engineering, I think these can roughly be brought in line with each other. But moving to the right, I think what was really interesting was actually the deltas in accuracy and stability that we saw. So accuracy is basically, hey, did you get it right? Stability is, did you get it right over multiple invocations of the same input and model? And we see almost 10 plus points difference in accuracy. And that's pretty substantial given kind of the complexity of these queries and to Vaishnav's point, the willingness of users to basically say, hey, if you don't immediately solve my query in one turn, I'm asking for a live agent and human support. And then it doesn't really matter what your AI model does because we've escalated to a human already. And so being able to get that first answer right is really important. And that 10 percentage point delta is pretty sizable. And like I hinted before, is really large in certain domains that require more specialized knowledge, which again, we'll get to in a few slides. The last column that I'll highlight, security. I think this was also less surprising than some of the other results, given the focus on safety that Anthropic's Claude has prioritized. And so we see that both Claude's Anthropic model as well as the domain-specific Aisera model basically score on refuting jailbreak prompts when provided by the user, whereas the other models, are very happy to respond. They're very eager to help, but they don't know when to not help when users provide malicious or bad prompts that should be avoided. And I think to just kind of highlight that last point about the domain-specific performance on security, to Utkarsh's earlier question about how do you level the playing field between these general purpose models and the domain-specific ones? One of the unfair advantages that a domain-specific model has is it knows I'm only answering questions about IT ticketing, right? And so anything that's not about that will immediately get disregarded by the model. And so there's kind of just this like prerequisite, hey, if it's not about this super specific thing, I'm not even going to bother trying to answer the user's query. That gives it a lot of security benefits in a way that you only get with a frontier model if you really bake in safety from the get-go, like they've done in Anthropic with some of the methods with constitutional AI and stuff like that. And so that is kind of a nice free benefit you get from using a model that really is only good, or not necessarily only good, but is really only supposed to do one very specific set of tasks and is really good at those specific set of tasks. Hopefully that gives a little bit of an overview of the results. And I would also encourage folks to take a look at the paper as well for more details on some of these results.
Awesome. No, that is great. Vaishnav, anything you want to add there?
I think Michael said it really well, and he said everything.
Okay, awesome. No, thank you. Thank you both. Okay, cool. So now we will come to the question of the hour, right? I mean, why domain specialization wins. The whole study is about, domain-specific purpose-built agents outperform general models, right? What is it? What do you think is this specialization? What do you think is in this specialization that makes such a significant difference? Like in this case, like you were alluding earlier, Michael, right? The IT domain or some domains are, perform much better than the others. Let's take an example of the IT domain. What is it that makes these domain-specific models better? And, what is your take on this?
Yeah, well, thank you for the question. And I feel like I've been hinting about it for a while. So
Right.
I'll kind of cut to the chase and get to the punchline now, which is, when you have a model that's good at doing something and it knows it's supposed to do that something, especially in these kind of more agentic, free-flowing dynamic environments, that's when you get the most bang for your buck in the same way that, I wouldn't be good at responding to IT support tickets, even though I would consider myself generally an intelligent person, but I know nothing about, the IT domain. And so what you want is someone who actually knows how to answer these questions and resolve user requests to be dealing with IT service tickets, right? Not someone like myself who has general knowledge, but not domain-specific knowledge. And, this is borne out in these results here, where, again, like I mentioned before, we do see very large deltas in terms of the model performance. Here we see domain-specific agent eclipsing 80% accuracy, while the rest of the models basically cap out at about 60%. So roughly a 20 percentage point gap in accuracy. And, that's also borne out with the rest of the metrics as well across the rest of the slide, as you can see here. And I think there's a few reasons for this. Like, I think one, the terminology, the domain-specific jargon is a big thing. And so, for example, you could imagine a user message that says help with PCI. And you're like, well, what does PCI mean? Well, it could mean PCI compliance, if this was the finance domain. It could mean peripheral component interconnect, if this is IT and computer equipment. Like, it can mean anything, right? And to Vaishnav's earlier point, like these user requests are typically only 20 or 30 characters long. So you only have a handful of words to figure out what the context is. Knowing that, hey, I'm working in this domain and I have this company's specialized knowledge kind of built into the system helps a lot in that sort of disambiguation. So I think that's a large component of it. I think to the security point, as I said before, knowing what tasks you're doing is also a big component of it. And then I think the other key thing that I highlighted before is the fact that there's just so many possible actions to take means that not means that just relying on common sense might not cut it, right? And so I don't know if we included this in paper, but some of these domains have 100+ workflows. The workflows themselves are like almost identical in a lot of cases. Like when I was looking at the data set, I had no idea what the right answer was. But if you were someone working at the company, hey, with this request, we're going to trigger this workflow, and this request, we're going to trigger this other workflow. Sure, they kind of have the same name, but like in my head, it's institutional knowledge. It's like tacit knowledge. We know at this company, that's the way that we triage and treat these different requests, right? Even to an outsider, it might look the same, right? And so how do you figure out which of these actions to take? I think that's where we truly see the benefits of these domain-specific systems, because they are able to better leverage that institutional knowledge in a way that is inaccessible to these general purpose external foundation models. So those are kind of the three things I would highlight in terms of why I think we see these large performance gaps in some of these more specialized domains.
Right. No, I actually relate to that. So from my perspective, I mean, talking to multiple, I guess, industries, customers, and teams, right? What I've realized is that every company has two levels of, I guess, hierarchy. One is the domain-specific hierarchy for, the departments that they work in, where they want an AI agent to address issues with. And within the domain, there is like task-specific hierarchy where, the tasks that belong to that domain. Now, what makes it really, I guess, unique to that organization is, like you said, there's a lot of ontology, there's a lot of language lingo, that is very specific to that company. So, for example, when I was at LinkedIn, we had systems like Azkaban and Goblin, and when I was just onboarding, I was like, "What are you? Are we going to read Harry Potter, or what's going on?" So, but agent is asked to answer questions for something like error 5, it has no idea what to do, right? And at that point, that's where domain specificity becomes such a big advantage, because if you train a model specific to a particular domain, then it's inbuilt, pre-built, to have a warm start versus trying to figure out through disambiguation and maybe some other knowledge that's not relevant to what the user is asking. So I completely relate to that, Michael, from my previous experiences as well. Awesome. Vaishnav, is there anything else to that insight? I mean, anything from your side?
I think you guys covered it really well, especially with like the examples of the domain specific jargon, and like Michael's example of like how as a human, even like as a generalist, you're not as good at like different tasks. But like one insight I would say is that like specialization matters more as the number of workflows increases, is something that we saw in our benchmark. So like for workflows where we had very few number of workflows, for domains where we had few workflows to select from, the delta in the performance of the domain specific agent was slightly smaller as compared to like the delta in like IT, where there were like 150 workflows to select from. So as like the complexity increases, a generalist model which might not have that kind of dense action space in training performs worse compared to like a domain specific model, which is more used to like working with all of those workflows.
Awesome. Thank you, Vaishnav. Great. So I guess I have one more question, or maybe a two-part question, right? I guess to bring us home, just to put together Classic as a as a practical framework. So maybe we can start with some of the common pitfalls, that happen in an enterprise environment. So in enterprise settings, when we often see AI agents being deployed, right? What according to you, and Michael, maybe we can start with you. What according to you are some of the common challenges, like maybe unclear metrics or misaligned expectations when deploying these these agents? And maybe you can answer the second part at the same time as to, how can Classic help, right? What are some of those actionable business insights to that?
Yeah, I think it's a great question. And I think really the main challenge is always like let alone, can we get the model to work? It's do we know if the model's working, right? I think answering that first question is often the hardest part, and it all comes down to evaluation, right? Can we accurately evaluate our models in ways that are relevant to the actual business needs that we're optimizing for, right? And I mean, I think evaluation is always a challenge, right? Even with humans, right? Like people do OKRs and all these different metrics and goals, but I forget the exact quote, but it's like as soon as something becomes a metric to optimize for, right? It's like all of a sudden now it's meaningless. Like it doesn't actually help you achieve your original goal. And so I think building internal evaluations is kind of one of the most useful and helpful things that a company, an organization, even an academic lab can do to understand if, hey, this approach, system, model, whatever actually solves my use case and not just this random benchmark that these academics published a year ago, right? And kind of to segue to your next question, I hope that is not what happens to Classic. And we've really tried to make this benchmark one of those living, breathing benchmarks where we are accurately capturing or reflecting as best as we can the real world production needs of enterprises deploying agents. And so again, I think we've done a great first step towards that vision of bridging the gap between benchmarking and real world production deployments. But I think there's a lot of exciting work to be done. And we'd encourage and really enthusiastically welcome contributions from other academics, from other companies, industry in general, to work with us and contribute their data to our benchmark so that it is better reflective of the unique internal needs of every single enterprise that might be interested in.
Awesome. Cool. Thank you. Vaishnav?
Yeah, I think Michael covered it again, but yeah, like absolutely, if like other companies are willing to share data from their enterprises, which is anonymized and like in a format where like no information is leaked, that would make the benchmark more representative and
attribute it to a benchmark like Classic so that others, including myself and other researchers, can evaluate and test and improve their systems on actual data that you care about.
So we did get a few questions through the Q&A. So I'll start with the first one. Based on these findings, what impact do you anticipate on future enterprise-focused AI agent development?
Yeah, I think that's a good question. I think there's a few things. I think this work just shows that there's a lot of value in building, more production aligned benchmarks, so to speak, benchmarks that actually reflect real world data. And I think that's borne out in a lot of the qualitative assessment we did, showing how the data set we curated looks very different from the leaderboards that you'll see in the public right now based on synthetic data, but also in the performance of models, right? Which only I forget the exact numbers, but they're in the 60s to 70s, right? This is not a saturated benchmark by any means. And so I think that just shows there's a lot of work to be done in improving these agents. So I think that's kind of the first high level takeaway from that. And then secondly, I think for researchers interested in the space, I think there's a lot of ways where our work can be expanded upon that I'm really excited to work on and hopefully see folks contribute to. For example, making it more dynamic, adding more multi-turn dialogues, expanding the number of workflows that we consider at each step, including new domains. I think there's just endless possibilities of how to build on our work, and I'd be very excited for researchers to take some of those steps and expand on some of the data that we've collected in that respect.
Awesome. Yeah, I'd like to add a few things as well. So I think what I really love about Classic is it's truly a multi-dimensional benchmark. I mean, in the past, as an enterprise AI practitioner, right, as an enterprise AI, I guess, provider, right, what we have seen from the Aisera standpoint is when a lot of companies that we work with deploy an enterprise AI solution, they're focused on, a single or, at the most, bi-dimensional attribute of measurement of enterprise AI agents, right? So for example, accuracy or cost, right? These are two things that I see a lot, but I haven't seen yet, a standard way of measuring an enterprise AI deployment across a truly multi-dimensional framework, a benchmark that could actually bring value to the enterprise. So I really hope and strive for a future where we could have work like this become a standard default of measuring enterprise AI deployments. And I think that will really help cut through a lot of noise, because today, if you look at CIOs, if you look at executive buyers, if you look at CTOs, they're all inundated by agents, and by people telling them that one agent is better than the other, but there is no real quantitative benchmark on proving that. So I really hope that the work done here becomes a step in that direction.
We'll now address the second question in the chat. Could you elaborate on the roadmap ahead for Classic and its potential industry adoption?
Yeah, absolutely. I can take that one. So I think the Classic benchmark today is just like a starting point for us. Our roadmap is to include more domains, integrate retrieval-based tasks to this benchmark, add more nuanced security tasks beyond just the jailbreaks, like prompt injection attacks and data leakage, and testing for those things which are very important in the enterprise use case. Most importantly, we want Classics, as Michael was saying before, to evolve as a community benchmark. That would mean like welcoming contributions from enterprises who can anonymize and share their real world data, so that we can have data from multiple vendors and not just Aisera, and we can have a more representative benchmark across the board. And ultimately, we hope that Classic becomes a reference point for vendors and buyers, so that when they're looking for evaluating agentic AI performance, they know like which one to select, and they have all the different things they're looking for at one place.
Thank you, Vaishnav, for the very insightful answer. And last question, what practical advice would you give organizations for their agentic AI journey?
I think, yeah, it echoes a lot of what I said before about the importance of internal evaluations. Like, I think I would basically, first focus on starting with that, developing that, creating a gold kind of test set, and then just being very rigorous about, measuring and indexing your progress as you iterate on different systems and models on whatever kind of internal benchmark you create. And again, hopefully, once you do that, contributing it to the Classic benchmark so that other external model providers and systems can also optimize their own performance against your specific business needs, so that in the future, you don't need to maintain and build your own benchmarks, but you can rely on a community resource like Classic and really take it at face value. So that would probably be my most immediate advice.
Awesome. Thank you, Michael. I think that was it for our session today. I hope you really enjoyed this webinar. Thank you again, everybody, for joining us. And thanks a lot, Michael. Thank you, Vaishnav, for sharing your insights with us. We really appreciate you being on this panel, and it was a true honor and pleasure working with you on this paper as well as doing this panel. So thank you.
Likewise, thank you so much for having us. It's been a really awesome project. I think hopefully folks will be able to download it, play with it. Oh, that's the other thing I didn't mention. It's available on GitHub, the code and the data. So if you're interested, please check out the paper link that Utkarsh shared in the first slide, which will also have a link to the GitHub. And so if you do want to test it, add to it, contribute to it, it's all available freely, open source on GitHub. So definitely please do check it out. Consider including it in your benchmarking efforts.